Welcome to Quadratics Level 1.2 Lesson Recap. So we're looking at the examples above on the very top, and what we're going to see is we want to know, how do you solve a situation where it's x squared equals 100, and how do we even treat that? Well, basically, we go back to our previous lesson, and what we're thinking about is that we have an area. Just really draw it there. And a very specific area that if we have a perfect square, all sides the same, and the area is given as 100. And we're trying to find the length of which makes one side. We know the area by definition is length times width, which in this case is x times x, and we say that's equal to area. In our case, the area is 100. So we can look at this as 100 equals x times x. Okay, now one way to write the x times x is x squared. We've already seen that in the previous unit. And now we want to undo the operation. So, as we've seen before, we want to undo the square. So we square root this. We square root this. Okay. Now here's where it's different from our radicals unit, because we're going to see something very unique here. X equals, well, it's the square root of 100, which is 10. That's fairly obvious if we have a geometric reality. But in our previous lesson, we also learned that how do you get a positive 100 could also be, or we could have a length of x equals negative 10. Because we saw before that negative 10 times negative 10 could also produce a positive 100. And so technically, what we're doing this algebraically, and not just limited to geometry, is that x equals 10 or x equals negative 10. So we have two answers that are possibilities now. Let's go to the next one. Okay, let's scroll up here. I have, and the second example would be the idea of p squared equals 49. Okay, we don't know what p is. We're trying to find that. Again, we visualize this as an area, and this is the side length. If I can spell it right. And we're trying to assume, because the only we saw last lesson, that the only way for this to be solved as an area is we have to form this as a perfect square. So if we draw it out, not very greatly, but 49, and we're trying to find that this is made up of p and the distance p. Algebraically, if we start off with p squared equals 49, we want to undo the operation of square, so we square root both sides. What we're left with is p equals 7. And we just explained that we can get a positive 49 with this key concept, or p could be negative 7 if it's not just merely geometric. Now what you have is that you can get two possible answers from solving squares here when we're given positive values. So you have some practice problems assigned for you to try and see if you can manipulate those to solve for the unknown variables. I'm now going to move on to level 2. Okay, so we have these level 2 problems here that we have x plus 3 squared is 25. X plus 3 squared equals 25. Okay, again, if we were to think of this whole number here is our area, and this side length is here. We're trying to figure out what that is. We could draw it out. I was going to quickly use my, could have imported a square really fast, but that's okay. This is the slow version. Alright. So we have 25, and somehow this is a length x plus 3, And this is also the length, x plus 3. We're trying to figure out what the x is. Like before, we can take this whole component of x plus 3 squared equal 25. We can undo the operation of the square by square rooting both sides. So in this case, these cancel each other out. So we have x plus 3 equals, what's the square root of 25? 5. Or, we gotta leave this or here, this x plus 3 could also be the result of a negative 5, because we know that the negatives can also produce these positive numbers. I'm going to keep going on the left-hand side and solve for x. Currently, x has a plus 3. Well, what plus 3 equals 5? If we undo this, we take away 3 from this side, take away 3. Whoops, not 3. X equals 2. That's one answer. Or we take away 3 from this side, we take away 3, negative 5 minus 3 more is negative 8. So there's two possibilities of values for x. I'm going to use this one here, 2x plus 4 squared equals 4 for the next example. All right, 2x plus 4 squared equals 4, so I keep in my memory. If I can find my cursor here. 2x plus 4 squared equals 4. Again, this is the area on this side. And somehow, this is the length of the side. And we're going to figure out algebraically how to figure out what the x is. We've seen so far that if we square root this, it seems to be quite convenient for us. Okay. If we undo this, we have 2x plus 4 equals the square root of 4 could be 2. Or the original length, 2x plus 4, could be equal to negative 2. Again, that being the possibility of the negative of the root. I like to go to the left-hand side again. So we have 2x plus 4 equals 2. I'm going to first of all subtract the 4. And we're left with 2x equals 2. Take away 4 is negative 2. Divide by 2. And we get x equals negative 1. There's one possibility. I'm not done though, because there still is or sitting over here that needs to be tackled. I go back over here. I'm trying to get x. X currently is multiplied by 2. Add 4. We want to undo the 4 first. Undo the 4 by subtracting. Negative 2 subtract 4 is negative 6. And this is going away. That, oops, glitch out. 2x equals 6. Divide by 2. Divide by 2. So we get x equals 6 over 2 is 3, and it could be a negative 3. And we have or. So we have two possibilities of answers, that x equals negative 1 or x equals negative 3. Let's just get, that's level 2. Now there's some associated problems for you to try on the practice. Next page. We've watched the video. Are you watching me? Now you can try these ones as well. Okay, problem set 2, A, B, C, D. You can paste your work there on your Google document. There's also some practice 3 to see there's a little extra step to get over to our single area and a square on one side. There's some challenges in B and Z. Next, we're getting to level 3. This is when it's going to get much, much harder. I'm going to change my background just so it's clear and white. Okay, there we go. So we have this situation where we have x squared plus 6x plus 9 equals 25. Now this does not look like this, like we've been working with before. Because if it was like this, something squared equals 25, we could easily figure out like the previous one. This is level 3 specifically, by the way. So when I have my assignments about what type of thing you have to be doing, we're at level 3. Now, it's peculiar for your Math 10 if you were to work your factoring. Now, I'm not going to review your factoring, but if you were to factor it, guess what? This is in fact a perfect square expression. Namely, this is x plus 3 by x plus 3. And we're going to see this. I'll just show you here. X squared plus 3x plus 3x plus 9. These two combine in the middle. X squared plus 6x plus 9. X squared plus 6x plus 9 is in fact x plus 3 squared is 25. If you need an extra help asking me about how do you do some factoring of these things, that's what we're going to have to take a separate time to practice. But right now, I've reduced this thing back to a perfect little square and an area, 25. So now I can undo this square by square rooting the x plus 3 squared and 25, and being very careful because when I square root that hasn't been there, I create two realities. That x plus 3 equals 5, or x plus 3 equals negative 5. We've seen this already, actually. So minus 3, x equals 2. Minus 3, x equals negative 8. Or, there's two possibilities of answers. Okay, let's go to this one here of x squared minus 8x plus 16 equals 17. This will be the last example for this lesson. I just gotta move over this way, I guess. Okay, I'll keep that up there. And I'm gonna write it out. Okay. Black x squared minus 8x plus 16 equals 17. Now if we focused on just this, there's a reality where we can check to see, there's a shortcut. We saw in the last question that was x squared. Let me just move up here a little bit. There was that stuff from Math 10 you should have learned where this and these are related such that 9, if you square root 9, you get 3. 3 is also happens to be half of 6. So one of those interesting things you can do is practice those shortcuts from last year where, what's half of 8? Well, negative 8, well, that could be x minus 4. Square 4, 16. Check. Haha. 17. So this is from last year, x squared minus 8x plus 16. If we need some review, we'll talk about it in a Google Meet. X minus 4 squared equals 17. Good, we have something squared equals 17. Now, here's where it gets a little bit interesting. We square root both sides. And we get x minus 4 equals the square root of 17. From our last unit, we also see that this is not a perfect square. But let's just leave it as an exact answer, like we saw from previous units, where square root 17 is just simply square root 17. Or, okay, we have x minus 4 equals the negative times, or the negative of the root 17. Whoa, heavy stuff right there. It's whatever this is as a number, an approximation, and it's the negative value of it. Okay, let's go back to over here. We need to get x by itself, so we're going to add 4. And we really can't do anything for the simplification here, so it's just simply square root 17 and then add 4. And voila, we have what's called an exact answer, which we could type in our calculator, or estimate here, and then add 4. Well, square root 17, just bigger than 16, so it's like 4.1 approximately. But you know what? This is an exact answer. So this is the best format. Approximately, this is like 4.1, and then you add 4. Remember how we practiced doing that last unit? So that would be about approximately 8.1. That's the value of x. Okay. Our preference is going to be the exact values. And we're still going to get x by itself on this side now. We want to figure out that OR business. Well, the same thing. All we have to do is add 4. So we're going to get x equals the negative of root 17, add 4. So if you wanted to approximate, again, I'll just do the approximate. This is our preference, by the way. We're done technically if we stop here. It's nice formatting. But for practical problems, we need to solve things in real life. Well, this is about 4.1. Bam. And it's negative. And then you have to add 4. You may or may not need a calculator. It's about negative 0.1. If you want to know the approximate. We're going to stick with the exact values because it's less work. You're just done. It's considered formatted. Hooray. That is the examples for lessons 1.1, level 1, level 2, solving, and then level 3. And level 3, by design, are always perfect squares. All right, have a good one.